Water is essential for life, but the source of fresh water on Earth is limited. We need to investigate and develop new water sources to increase the supply of fresh water for daily life. One of the important water sources is groundwater. Some countries depend on groundwater as their drinking water. However, many groundwater sources are contaminated. Groundwater is a part of the water cycle. When water above the ground goes downward through the saturated soil, groundwater is then formed. The groundwater contamination is mainly due to the pollutants are released on the ground through the soil and down to the groundwater. Industrial waste, urban and commercial waste, leakage from underground storage tanks, uncontrolled hazardous waste, landfill and agricultural waste or other chemicals are some of the sources of pollutants. Drinking contaminated groundwater can result in health problems such as hepatitis, diarrhea, or irritations. In long term, the health problems are more serious. Disability to kidney and liver, nervous system problem, or even cancer may occur. What we are concerned is to provide new water supply. We would like to build a water treatment plant to treat the contaminated groundwater and pack the treated water into bottles that can be safely drank. In the contaminated groundwater, a chemical called arsenic is highly toxic and it is carcinogenic to humans. Drinking the groundwater with arsenic can cause cardiovascular disease, skin lesion, or cancer. In our plant, besides the common method of water treatment, we will also remove arsenic from the contaminated groundwater, so we can provide new and safe water supply. Let's see how we can get the groundwater to our plant. As the groundwater is a part of the water cycle, it is a major contributor to flows in many streams and rivers. The top of the surface where groundwater occurs is called the water table. Below the water table is the saturated zone with water. If the saturated zone is shallow and permeable enough to allow the water to move through it at a rapid enough rate, then we can withdraw the water to our plant. Since the water table level will change from time to time, and the groundwater flow rate is various too, we will adjust the rate of restoring water to our plant. To locate a suitable source of groundwater, starting with our hydrologist targets and area, we test and study to identify the hydrologic and geologic features of the area. Second, we use geologic maps and cross-sections to show the distribution of different kinds of rock on the surface and underground. Then, we obtain information on the well in that area. By doing the test, we can determine the amount of water moving through the zone and the effect of pumping on water levels in the zone. After all this research, we can obtain enough information of the source. If this source is available for us, we can pump the water from this area to our plant and start the first part of the water treatment.
As the contaminated water may contain solid impurities, the process based on sewage water treatment are used to purify the water before filtering the arsenic. There are 4 main steps: preliminary treatment, primary treatment, secondary treatment, and tertiary treatment. Let's have a look at preliminary treatment, which is also called scanning. It scans heavy inorganic solids, oil, and grease. In this treatment, bar scans, grips chambers, pre-aeration tanks, and septic tanks are used. To prevent the damage of pumps, bar scans and long grips chambers accumulate the heavy inorganic solids, for example sand. The water flow rate is low here to have a great accumulation. In pre-aeration, grease and oil are separated from water in sedimentation tank. Air is added to flocculate lighter suspended solids and provide aerobic conditions. Pre-chlorination is then used to destroy odors and slow down the bacterial decomposition. When the bacteria are in excess, adding limited chlorine can temporarily reduce biological oxygen demand. Second, primary treatment, which is the sedimentation and flotation in septic tanks with lower water flow rate. For septic tanks, the lighter suspended solid flow on the water surface, and denser suspended solid are precipitated at the bottom. After 2 to 3 hours, 40 to 60% of suspended solid can be removed. Within the primary treatment, chemical enhanced primary treatment increase the removal of total suspended solid. The water mixed with fluid chemical and alum absolutely and quickly. The reaction with fluid chemical can remove sulfide, phosphate, copper, and zinc. Sulfide and phosphate has higher removing efficiency. They are at least 95% and around 90%. For alum, it's cooperate with fluid chemical for coagulation and clump together with charged particles to help filtration. Around 45 minutes, the removing efficiency for total suspended solid and biological oxygen demand are 80% and 60%. The secondary treatment is biological treatment. The rotating biological contactor inside contains a series of closely packed circular discs with bacteria on the surface. The discs are partially submerged into the water and slowly rotate to provide enough oxygen for algae. The algae convert organic compound to carbon dioxide and water at high efficiency, which below 30 degrees Celsius. After 24 hours, the treated efficient will meet the standard of 30 mg per liter total suspended solids and 20 mg per liter biological oxygen demand. The last treatment is tertiary treatment, a combination of physical and biological process for advanced removal of nutrients, organic materials, and remaining suspended solids. It also ensures that no bacteria are remained and maintain a biological oxygen demand level less than 10 mg per liter, suspended solid level less than 5 mg per liter, pH range from 6 to 8, and at 20 degrees Celsius in the outlet stream.
After the tertiary treatment, we will focus on how to remove the arsenic in the water. Arsenic-free and arsenic fine are fine in the water, but we can only remove the arsenic fine by using ion exchange. Since the pH of the arsenic-free is about 6.5 to 8, it affects the efficiency of the catalyst. Also, the efficiency of the removing the arsenic-free is lower than that of arsenic-fine. So we will oxidize all the arsenic-free to arsenic-fine with hydrogen peroxide, which is a powerful oxidant, and after the oxidation, these oxidants decompose to non-toxic chemical, that are water and oxygen. Besides, the price of the hydrogen peroxide is cheaper than other oxidants.
After that, arsenic ion is removed by using ion exchange. You can see here is a tank which is full of resin. The resin that we use is SIR 900, which is an aluminium absorbent. The pH value should be set between 4 and 10, and the temperature should be set below 100 Celsius. Although arsenic ion can be removed in different ways, like electrocoagulation, ion exchange is better. When using electrocoagulation, the sacrificial electrodes are dissolved into wastewater streams as a result of oxidation and need to be regularly replaced. Also, an impermeable oxide film may be formed on the cathode, leading to the decrease of efficiency. We are going to remove transition metals after arsenic removal. As the concentration of transition metals in groundwater is definitely higher than surface water, we need to remove transition metals carefully. Chelated ion exchange resin usually has a higher preference for transition metals, so transition metals can be removed clearly by ion exchange. The resin that we use is SIR 300, which is a sodium-form macroporous chelating weak acid cation resin. Also, the pH value should be set between 1.5 and 14. Finally, the temperature should be set below 50 Celsius. After removing arsenic and transition metals, we need to kill the microorganisms. Microorganisms are killed in UV disinfection system. Let's see how we package our water.
Packaging process is separated into two parts: internal and external packaging. Internal packaging refers to combining bottles, cups, and water, while external packaging means the labeling and carton packing. In the bottle cup molding process, PET will be used as a raw material. It combines to form a bigger plastic ball. Using a high-pressure compressor, the ball becomes cap-shaped. The cap is then passed through a splitting machine to form the cap and the cap ring. Afterward, they enter the printing machine. In the bottle molding process, the new polyethylene terephthalate (PET) and the fluid of recycled PET from the compressor are mixed in the mixer. Next, the mixer will pass through the injection cycle. Within the cycle, the mixer will heat up to over 316 degrees Celsius, so it can convert to the liquid phase. After that, the liquid plastic is shaped to be a preform in high pressure. To increase the efficiency of the injection cycle and reduce the cycle times, secondary cooling is needed. The cooling can be performed by either using a cooling block or staying on the second set of injection cores. After the temperature of the preform is stabilized, it will be heated to the optimal temperature of molding by halogen heating lamps. Then, the preform is rotated to a blow molding station. There are three main components in the station: a blow pin, a heat preforms, and a cold mold wall halves. After the preforms enter the mold, it will enlarge due to the injection air is blown by the pin. Finally, the bottle is ejected by the machine. After all the molding process complete, the bottles will be washed and filled with water. The combining and cabling of the bottles will be done by the machine. Then, we are going to the external packaging. Label the bottles and convey to the carton packer. Now, our water alias is ready.
Wow!
To ensure our process, equipment, system, machinery, and also our product alias can meet the country's regulation, quality requirements, and ISO international standard, we will use the quality assurance and quality control service provided by SGS. If all the requirements are passed, a certificate from SGS will be given to show our process and products are safe to use.
We can get the advantages on removing the arsenics from groundwater. The first one is developing our new water resources, and the second one is using the extracted arsenics as the raw materials to manufacture different products. Moreover, this water treatment plant is not just to our advantages, but also provide future development. One of our concepts is the health of people that are affected by drinking contaminated water source in poor countries like Bangladesh. Our future plans is to develop the water treatment plant in those countries so as to improve their living environment. Besides that, the technology of our water treatment plant can be applied in two other ways. For larger scale application, as one of the sources of arsenic is from industrial factories, we can apply the technology to remove the arsenic before the water enters the sea. For small-scale application, we can design some daily use product with the technology to provide arsenic entering our daily life.
And this is our process flow diagram.